One of the most important element of creating flow in office areas is the resource balancing. So in this element, the first step is to see our process flow diagram which is being performed in that area or in that office, and see for and document for every step how much time every task needs. It's 1 day, 1.5 days, 2 days, and how much time we require. This could be sometimes very difficult because people might be reluctant to give this information, that how much time they have to spend on which task. That's why it's important here that the trust is there between the consultants and the employees, that this information will not be misused, and there should be the assurity from the management side that office lean management is for the benefit of the whole company and will not have any negative consequence for the employees who are participating in that. And also, it's not that difficult nowadays because of the softwares or the data entries to calculate when a task was started and when a task is ending. When one entry was done today, the next step is being started after 2 days. We know for this task it's taking 2 days, and there could be some variability from day to day, from task to task, but the average could be used to have the rough estimation which task is taking how much. So in this first step, we are, for all the steps being taken in office, we are writing what is the required processing time for these tasks. So in this example, you can see that there are 7 tasks which needs different time from 1.5 days to 2.8 days, and in total the total time is 18 days, and these tasks are being performed by 4 employees. The next step is to calculate the number of resources required, the number of FTE, full-time equivalent, or the staff members required, and this is calculated by this formula that we divide the total processing time that we have seen in the last slide, 18 days. This total processing time in order to perform all the tasks divided by the customer tucked, which we have previously calculated, and multiplied by 95%, which is the efficiency, which gives the 5% of room or relaxation for the employees, plus 10% buffer. So 10% buffer is the buffer in capacity. There might be some errors in the calculation when we calculated how much time we required for the task, or there might be some undocumented tasks that people have to do, or there can be slightly deviations in the demand, little bit demand. In order to cover small increase in demand, we always keep a little bit 10 to 15% of buffer, so that our tasks are not stucking somewhere because lack of capacity, so that they are flowing very easily through the system. So this is the formula, and filling the values in this formula from the previous example, we can divide the 18 days required to perform in this area all the tasks divided by 9 days of customer takt time. Every 9 days we have to deliver one task, multiplied by 95% plus 10% buffer. This gives us 2.32 FTE, full-time equivalent, or staff members. And when we compare this with the currently employed number of employees in the system, that is 4, we can see that the tasks require, even after 10% of buffer, 2.3 or 2.5 or maximum 3 employees, but we have 4. So in these conditions, we know that there is productivity loss. We are here losing the productivity. So this gives us clear picture that we need to go into more detail and see which operator has more room or which operator is working more than required, if there is a balance between them. So this resource balancing we are going to do next step. So for resource balancing, let's visualize the information we have so far in a graph. Here in this graph we can see that we have here 7 tasks which are performed by 4 employees, and we have the customer target of 9 days. It means all these activities which are being done in one project, that project has to be delivered within 9 days. So in this case, we can see that the line balancing factor is here 72%. So this line balancing factor will be 100% if all the employees have same number of or same amount of work content to provide. So there is no employee who is waiting. But in this case, we can see that the employee number 3 who is performing activity number 4 is bottleneck process. So the employee 1 and 2 and 4, they have to wait for this employee until this employee is not finishing his the activity. The task from the previous employees is not coming to him and it is not flowing further. In this case, we don't have the problem of delivering the customer in time. The customer target is at 9 days and all the activities are below this tag time. So it means we will be able to deliver these tasks to the customer within 9 days. But here in this office area, the main problem is the waste. If we see the line balancing factor of 72%, it suggests that some of the employees are waiting because one employee is busy doing his task, and this waiting time for these 3 employees, employee number 1, 2 and 4, this waiting time is the loss of productivity, and it is 28%. 72 is the factor of line balancing, and that means if we don't have 100% line balancing, it means there are now losses in this process. So this sink the productivity in office area. If we shift these tasks and reallocate them in a way that we still remain under the customer target, so means our speed of delivering these tasks is still quicker than the customer is asking us. In that case, we can remove the employee number 2 and 4 because they are not required, because the tasks could be performed by the employee number 1, 3, and still we are below the customer demand. By doing this, these 2 employees could be used in other department or for other tasks, and this will help the company to perform to deliver the project with 50% less resources. So we have certainly increased the productivity where it was waste in the past. Now we are utilizing. But here a small issue we see the employee number 1 is still not able to 100% meet the customer requirement, because customer requirement is every 9 days and it is touching. So we don't have here the buffer of 10 or 15% in case some tasks have some difficulty and they cannot be completed on time, or we couldn't receive the feedback from any other department, or something goes wrong. So we need 5 to 10% of buffer. So in that case, the next element comes into play, which is workload.